Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. To answer this question, we need to cut this shape into two shapes. So we're going to draw a line across here, and we're going to cut it into a rectangle and a triangle. Now we need to first of all label the parts of the triangle. So the length or the width of the triangle, the base, will be the same as the base at the bottom, so that will be 20 centimeters. And we need to find the height, which is this length here, which is 90 degrees to the base. And to find that, what we can look at is the fact that the total height of the whole thing is 13, and the height of the bit we don't want is 11. So what's left over? Well, 2 centimeters will be left over, so the height will be 2 centimeters of the triangle. So let's work out the area of the triangle first. Which is going to be half times base times height. Half times the base, which is 20, times the height, which is 2, will just give us 20. Now let's work out the area of the rectangle. And that's just going to be the width times the length. Width is 20. The length is 11, so that would be 220. Then to work out the total area of the whole thing, we're just going to add those together. So 220 plus 20, which is 240. The units are all in centimeters, and so the area units will be centimeters squared. For mutually exclusive events for A and B, the probability of A or B is equal to the probability of A plus the probability of B. Now we're given the probability of A or B, which is 0.36, and we're given the probability of A, which is 0.12. And so to work out the probability of B, all we need to do is going to solve this. We're just going to take away 0.12 from both sides, and that will give us 0.24 is equal to the probability of B. So B must be 0.24. It only works if A and B are mutually exclusive though. So we have an original amount, and this represents 100% of the original amount. The new price, new amount, represents 113%, because it has said that it has gone up by 13%. So it has increased by 13%. And as a value, that increase is £1,287. So it's 13% of the original. It's gone up 13% of the original price. So what we're going to do is we're going to work out what 1% of the price increase is. Instead of 13%, we're going to work out what 1% is. And we're going to do that by dividing the amount by 13, and we get 99. So 1% represents £99. So 1% of the original represents £99. But the new amount is 113%. So we need to times the £99 by 113, which gives us £11,187. So the picture is now worth £11,187. There are a few different ways of finding out product of prime factors. I prefer using the bubble technique. So we just write the number out and we put a bubble around it, and we split that number into two numbers. So we find two numbers that multiply together to make that number. Now, I always pick the smallest that I can on the left-hand side. Now, the smallest I can think of is 2. and so 2 times 22 is 44. And now we think about 22, and that's 2 times 11. Now you might be thinking, why have I put the 2's in red? The reason why I've put them in red is they are prime numbers. We can't do another thing for the 2. Well, we can, it would be 2 and 1, but we'd be there all day doing 2's and 1's off the 2's. So we leave it as they are, and 11 actually is a prime number itself. So if I'm going to keep up with the theme, I can have that in red as well. Now, notice it says product of prime factors. So the prime factors are 2, 2 and 11. But the word product means times. So it's 2 times 2 times 11. Notice they're in ascending order, so it's 2 times 2 times 11. Now, if we were asked to do it in index form, we would write it as 2 squared times 11. To find the exterior angle of any polygon, we do 360 divided by the amount of sides. These are decagons, which means they have 10 sides. So the exterior angles will be 36 degrees. And the exterior angle is just an angle that kind of continues on. You just continue on from the side. So this one here is the exterior angle of the left-hand decagon, and this one here is the exterior angle on the right-hand decagon. So altogether, the angle A will be 36 plus 36, which will be 72. So our answer will be 72 degrees. We've got to first of all work out how many parts there are altogether in our ratio. So we've got 51 saying yes, 7 saying no, and 13 undecided. So altogether, we've got 51 plus 7 plus 13, which is 71 parts. Now each part is equal. So to find out the value of one part, we're going to do how many students there are, which is 2,911, and divide it by the 71 to find out what one part is worth, how many students are in one part. One part's worth 41 students. So each one of those parts in the ratio is 41 students. Now yes, because it goes yes, no, undecided, yes will be the 51 there. So it's 51 lots of 41 students. 51 parts with each part representing 41 students. And when you multiply those together, you get 2,091. So our answer is that 2,091 students responded with yes. The formula y equals mx plus c includes this m, and the m means the gradient. So if we're looking for something that is parallel to y equals 9x plus 18, we're looking at this number here. And for it to be parallel, it needs to have the same gradient. So we could just write y equals 9x plus or subtract anything. Or we could just write y equals 9x. I'm going to say plus 5. So we know that 171 is 3 times 3 times 19. And what we do is we just compare 171 with 342. And we know that 171 times 2 is 342. So therefore 342 will have the same prime factors as 171, which is 3 times 3 times 19, but it will also have a times 2 in there. So the answer will be 2 times 3 times 3 times 19. So we're going to write out the question again, just to give us a bit more space. And we're going to put in our tramlines so we can solve it. Now we're going to solve this in exactly the same way as if it was an equation with an equals in the middle. One slight difference though is if you times or divide by a negative, you've got to flip the sign, but hopefully we won't do that. Now the rule when you've got an x's on both sides is you get rid of the smaller amount. So we're going to get rid of that 4x from both sides. So we're going to take away 4x both sides. And so we're going to have 3x plus 8 is greater than 23. And then we're just going to solve this normally. So take away 8 both sides. And that will give us 3x is greater than 15. and then we're going to divide the 3 both sides. And that will be x is greater than 5. In this question we have a right angle triangle and we know 2 of the sides and we're looking for the third one. So that screams to me Pythagoras. So Pythagoras is a squared plus b squared equals c squared, with c squared being the hypotenuse. The hypotenuse is the one opposite the right angle, so this is going to be c. And we'll label the other ones a and b, it doesn't matter which way around they go. So a is 5, so it'd be 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. And so 25 plus 144 is 169. Now that's c squared, so we need to solve here, and the way to solve is just to square root both sides. And so it would be 13 equals c. Because it's distance, we don't worry about the negative 13, so just the positive 13. So we know c is 13, so we need to know what the total length around the triangle is. So we're going to add the 5, the 12 and the 13 we've just found. When you do that you get 30. So we know there's 30 meters in total. Now it does say that we need 90 milliliters of paint per meter of wood. So the amount of paint needed is going to be the 30, because that's the total distance, times the 90, because we need 90 for every meter of paint. 3 times 9 is 27, and then put the 2 zeros at the end. So the answer is 2,700 milliliters. First thing we notice is that there is a square here, so we can work out what this length is going to be. It's also going to be 40 centimeters. And whenever we're working out the area of a shaded area, we're normally working out the area of 2 shapes and subtracting one from the other. And this question's really no different. So we're going to start off working out the area of the square. And all we need to do now for that is 40 times 40, which will be 1,600 centimeters squared. I normally only put units in our answer. The next thing we're going to do is work out the area of the circle, but to do that we need to work out what the diameter of the circle is, and if you notice that the diameter of the circle is just 40 degrees. It's the same as the width of the square, or height of the square. So if the diameter is 40 degrees, the radius would be 20 degrees. So for the circle, for the area of the circle, we're going to do pi times the radius, which is 20 squared, and 20 squared would be 400, so this will be 400 pi. This question's asking us to leave it in terms of pi, so we're going to do that. Now next we're going to work out the all of the corners, so that includes these 3 here and this one. So I'll say, like, I don't know, 4 corners. Just try and explain to the person marking my exam what I'm doing. And to do that, we're just going to do the square, take away the circle. So 1,600, take away 400 pi. Now we can't actually do anything more than that. That is our answer. So it's just, we just leave it at that. And to work out just the shaded bit, which is this bit here, they are 4 equal amounts that we've got for these corners. So just one corner, which is the shaded bit, will be the 4 corners divided by 4. Now we've got a kind of fraction here. We can divide all of the terms by 4. So that will leave 1 at the bottom, 100 pi here, and this will be 1,600 divided by 4 is 400. So we're just cancelling the fraction, and actually we leave it as 400 minus 100 pi, and that indeed is our answer. You can't simplify that any further. So we've got to first of all understand what standard form is, and standard form is a number that is between 1 and 10, but not including 10, times 10 to the power of another number. So to find out what the number's going to be for our standard form, we're going to just write down the decimal first, so 0.098. And we've got to put a decimal point in somewhere to make this a number between 1 and 10. So if I put it in here, that would make it 9.8, and we're ignoring the zeros to the left-hand side. So we know that our standard form is going to start off with 9.8 times 10 to the power of something. Now this times 10 is always going to be there. It's never divided by 10 or anything like that. It's always times 10. Next, we've got to find out what the power is going to be. So first of all, if it's a small number, if it's a number less than 1, which this is, it's a small number, it's going to be a negative power. And the next thing we do is work out how many jumps we had to do. So it would be 1, 2 jumps between where the decimal point was and where it is now. So 2 jumps means it's going to be to the power of -2. So there are 2 outcomes that it will rain once in the next 2 days, and that will be rain and not rain, and not rain and rain. So to work out the probability, it will rain on Monday and then not rain on Tuesday. What you're going to do is just multiply 6 over 20 by the 2 over 7. So 6 over 20 times 2 over 7. And that will give us 12 over 140. And to work out the probability, it will not rain on Monday and rain on the Tuesday. We're just going to multiply the 14 over 20 by the 5 over 7. And so that would be 14 over 20 times 5 over 7. And that will give us, 70 over 140. Now we're looking for the probability it will rain and not rain, or not rain and rain. The word or in probability means add, so we're going to get that 12 over 140 and add it to the 70 over 140, and that will give us 82 over 140, and then we can cancel that down to 41 over 70. To find the interquartile range from a cumulative frequency graph, you first of all see what the graph goes up to. Here you can see it goes up to 20. And what we do is we halve that, and that's the value we use to find the median. So we halve that again, and that's the value we find for the lower quartile, which will be 5. Then you add the 5 to the 10, so the number we use for the lower quartile to the number we use for the median, and we get 15. So those are the 2 points there that we will find our quartiles. So we draw a line across to find our lower quartile, a line across and down. And I think that is roughly, I think 22 roughly. We do the same again for our upper quartile. Line across and down. And that's roughly, I mean, these are going up in 4s, so maybe 37. Because this line here would be 36, that would be 37. So to find the interquartile range, it is interquartile range, let's do the formula, is the upper quartile, take away the lower quartile. Upper quartile is 37, lower quartile we said is 22, and so 37 take away 22 is going to be 15. Now if you've got slightly different values, that's absolutely fine. The exam will always give a bit of leeway, especially when reading off graphs. So when we find the mean of something, we add the elements together and we divide them by the amount of elements. So here we've got 3 elements. So what we're going to do is add these together and then divide by 3. Now the problem is that the denominators are not the same, so we can't add them yet. But they're all factors of 45. So we're going to times top and bottom of the first one by 9. So we end up with 9k over 45. Times top and bottom by 3, and so it would be 3 brackets k plus 1 over 45, and the last one is over 45, so we don't need to do anything for that. Then we can just add the numerators together, and I'm just going to expand the bracket here, so it's 3k plus 3 plus k plus 4. and then all of that over 45. And then we're going to do 9k plus 3k plus k, which is going to be 13k. And then 3 plus 4, which is just 7 over 45. So the sum of them is 13k plus 7 over 45. So to work out the mean, we need to divide it by 3. But instead of writing divide by 3, we know KFC, keep, flip, change. If you have a division, you keep the first fraction, you change the divide into a times, and you flip the second fraction. So a different and easier way of writing that is times 1/3. So here we just keep the numerator the same because we're timesing it by 1. And then the bottom we just times by the 3, which would be 135. So our answer is 13k plus 7 over 135. We can write the equation of any linear graph as y equals mx plus c. So m is the gradient and c is the y-intercept. So we've got to find what the gradient and the y-intercept are. Well, I'm going to first of all try and figure out what the gradient is, because we're actually given some clues here. We're told that the line is perpendicular to the equation given. Now I'm going to rewrite this a little bit just to make it a bit clearer what the gradient of this is. So I'm going to write this as minus 1 over 12. I'm just going to leave a bit more of a gap there. Minus 1 over 12 x plus 12. And you can see that the number before the x, the coefficient of the x, is minus 1 over 12. But we're not told that it's parallel to that, so it's not, the equation that we've got is not going to have the gradient as minus 1 over 12. We're told it's perpendicular. Now, when two things are perpendicular, to find the gradient of the other one, if we know one of them, you've got to change the sign and find the reciprocal of the fraction. So to find our gradient, we're going to change the sign, so it's negative, so our gradient is going to be positive, and we're going to flip it. We're going to find the reciprocal. Reciprocal of 1 over 12 will be 12 over 1, or just 12. So the gradient of our line is going to be 12. To find the y-intercept, we're going to use the points given to us. So we've got x equals 3 and y equals 4 for a point on our line. We're going to substitute those into the equation we've got. So it's going to be 40 equals 12 times 3 plus c. Put in our solving lines. 12 times 3 is 36. And we're going to take away that 36 both sides. So it's going to be 4 equals c, or c equals 4. So our equation will be y equals 12x plus 4. So if the area of the rectangle is 10 and one of the lengths is root 75, to find the other length we do the area divided by the length given, and that will work out what the other length is. Root 75 though is something that can be simplified, so let's simplify that. And it's root 25 root 3, so it's 5 root 3. So this equals 10 over 5 root 3. Now notice top and bottom can be simplified, so that becomes 2 over root 3. And we're asked to rationalise the denominator, so we're going to times this by root 3 over root 3. And so we end up with 2 root 3 over 3. So our answer is 2 root 3 over 3. So we're told in the question that y is inversely proportional to the cube of x. So we can show that by y is proportional, there's proportionality, inversely, which would be 1 over the cube of x. Now to convert that alpha, the proportionality symbol, into an equals, we need to introduce a constant to the right hand side. So we get y equals k over x cubed. And all I've done to the right hand side is multiplied it by k. Okay, now we need an instance where we know what y is when x is something, and here we do have that. or it should be the other way around, what y is, well, yeah, what y is when x is something. So we've got y is 10 and x is 7. So we're going to feed those numbers into this kind of equation that we've made. So it's going to be 10 equals k over 7 cubed, or 10 equals k over 343. Okay. And then we're going to multiply both sides by the 343. So times by 343, both sides, to find out what k is. And I'm just going to swap them around just to give myself a bit more space. And we're going to have k on the left-hand side here. So that would be 3,430. So k is 3,430. So what I'm going to do is just rewrite this equation here. But we know what k is now. So it's y equals 3,430 over x cubed. And that actually is our answer. So I'm going to, first of all, just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, and I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put little notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. That's why it's a nice, easy way to show that A to M is 1/5 of that distance. Let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now, if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M. And we know that that's going to be B to A plus A to M. We know B to A because it's labelled, it's just A. And we know A to M because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 A plus 1/5 B. And so A minus 1/5 A is going to be 4/5 A. And then we've got the 1/5 B. So it's going to be 4/5 A plus 1/5 B. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.